You know what? I think I can just jump on a second part, another thing inside of that list that's very, very relevant to making the crawlers work well.
Okay.
It's like tied in between. So I think I had somewhere in the list data-based events or
Well,
something.
that is perfect because that is currently leading in the poll right now. So,
Really?
yeah,
Oh,
yeah,
okay.
yeah.
Yeah. So this is, riffing off when you talked about how damage propagation in your damage system. I don't remember exactly what you call everything, but it's like a pretty good way of dealing with damage
Yeah,
and
kind of like the capability system and having the damage events and all that. Yeah.
yeah, yeah. So let's just get a few ground rules here around how we should view this problem. So first of all, um, problem with the crawlers, or not the biggest problem, but maybe the biggest. I haven't really seen, but one of the actually biggest thing isn't really the movement code. Uh, that is continuously updating, right, and doing all every frame, and it's very, very necessary to optimize as fast as possible. But an equally big problem is the cascade of things that happens when you kill them or something else would happen with them. So imagine when you shoot one crawlers, you're supposed to have a sound, a VFX, and then maybe count up some counter that you call that kill them, and then maybe spawn some remnant of some sorts. So there's like, and imagine you're having like a shotgun and you shoot like 100 projectiles and you kill like 50 crawlers at the same time, and then all the crawlers have like, I don't know, 10 different sub things that happens because of their death. Then you get
Like maybe they
500.
play an animation or do some sound effects or add to the
Yeah.
score of the player or something.
Yeah. Oh, animation. Let's keep that on the back burner. I can show you how they are animated after we're done with this one.
Cool.
But yeah, the cascade effect is very, very hard to deal with. And in Unity, traditional Unity, you have the problem like, oh, I want to have a lot of enemies, and then you shoot one and you make a really cool effect, and then you put in the death effect, and then you put in 100 enemies, and you throw a grenade, and it just like lag spikes because you
Yeah,
are
yeah, yeah.
instancing 500 explosions. Unity game object dot instancing is like the slowest shit ever. It's super bad. But dots doesn't really solve it all the way either. You still have to deal with effects and stuff that is not dots
Right.
compatible
Yeah,
yet.
yeah, yeah.
And even if everything was dots, you still would probably run into issues with the frame dip or spikes when you have this cascade. So how do we deal with this? Part of it would be like to rate limit it over frames, and that's also something I do. And that's, you can imagine how that is. You have a backlog, and if you go over a certain threshold, you throw it into the backlog, and
Right,
you wait
right.
for the next frame and stuff like that.
Smart, yeah.
But this cascade, part of the reason why it can be so slow is if you use slow systems like entity command buffers. Entity command buffers is great when you're dealing with, and it's very, very versatile when you're doing this, the example you had last time. Then it's a perfect solution for it. But if you have 50 of them having at the same time, then in the same frame, that's going to be a problem. So now it's the data without entity. Remember, one of the reasons why entity is a thing is because it needs to be globally addressable. Like you have this entity, you have a bunch of data connected to it, and you want to be able to identify that one, right? That's part of the reason why you have it as an entity.
Right.
But in your case, with your damage, or with my case with damage, or with something else like an event that happens, the identification of the event does it's not necessary. It's just like this victim got hurt with this damage. Like the identity of that data is not really relevant. It's just like you got hurt. Like my identity as a messenger is irrelevant in that case. So you have this entity with an ID that is perfectly globally addressable, has no real use. Like when you read the incoming damage events, you didn't care about the entity index, right? It's you have your damage and you have the target which take the damage and that's it, right?
Right. Yeah. I think in that case I didn't, but I do see that there are like some times where you might want that information as well.
Yeah, but also like also there's a difference here. You don't necessarily need to be globally identified. You could have a
Okay.
local identification, but entities is globally identified amongst every entity in the whole system, right?
Right.
And
Right.
that's
Right.
not
Right.
really relevant for a lot of stuff. And this applies to a lot of situation. Like ask yourself before you make it an entity, like, is this really needed to be identified, or can I like do it without this global identification process? So let's take a look at the damage events, because that's one of those things. So if we look at this one, we have a few things here. We have some information about the position, like where it's got hit. So this is like a damage event. So where did the damage occur? Then we have an attacker, which is an entity. We have a victim, and we have a possible subpart. And then we have some a reason. So this is like removed, killed, self detonation, stuff like that. And we have some other data, and we have the damage. Could be a good thing to have here also, right? But if we look at this, it's not an eye component data, right? So what's happening here is that I just have a native queue of that. And when I do something, let's see here if I can find some place where it's used. Oh, this is only on self detonation, so this is not really the most relevant part of the system, but basically only self detonation. Um, this is when I kill myself, basically, or the crawler kills itself. So I just enqueue this, and this is a parallel writer. So I send in an let's see here, damage signal. Was it that one? Yeah, that one. So I have this damage signal system, which grabs me a native queue. It creates a native queue for me, adds it to a list, and sends then the parallel writer version of it. So my crawler system can just start putting in damage event into that one if they want to. If they want to if they want to self destruct, they just, oh, this is my event that I want to self destruct, and they identify themselves and they send it away. And this signal system, it's a signal system that I built that is based on the system base, right?
Mm-hmm.
And the thing is, like, this, it just has like a way to create native buffers or native queues with a specified type. And so you just like ask all of the system, you ask for this this a queue, and say like,
Mm-hmm.
I want the queue with this stuff, and I want to produce it. And then when you let's see here, it's tricky with this resolution thing. I'm sorry if I'm being slow here. It's And then when I get to the update of this function of this system, um, I come here, and I then have the damage system. Where is it? Data buffer, a lot of stuff here. So here I have the list of native queues. So different systems all over the frame have created, I want a native queue, and they fill damage events into it. And then I go through all of them, and I pick them out as arrays. So this is just converts a native queue to an array, and I put them into this list, a big list, a list of a list actually, but I just make sure that I accumulate everything in a list that is easy to digest, and then I consume them in a job. So I just have this job which contains just a big native array of all the damage events. But here's the thing, like all of this system produces these damage events, which is just structs straight up in native collections. And nowhere in this whole system is there ever a structural change, because this has nothing to do with ECS. So when I pick this out, um, damage signal, I got all of this data. If it want to give me, yeah, the attacker, the net ID, the damage, and all of this, it's there for me. I can just go through it easily, but there's nothing around here. There's a component. It's just data.
Right. And now you don't
Yeah.
have to worry about dependencies or anything. It's just all, yeah.
Yeah, and this isn't parallelized, this code here, because you can't do that. You need to have a single frame. So when I apply the damage on the different stuff, then that could obviously be structural changes. But that's like applying the damage in the end. That's just using the data. The communication of the data, the pulling all the data into a single point and then just like dealing with it. All of that is completely everywhere in this whole game, void of any structural changes. And that's true for like most of the events in the whole system. There's like 2 or 3 events where I use entities to like have a handle for it. But that's for other like reasons, and that's often like events that rarely happens. Like these guys, this the damage event, they can spew like tens and hundreds of them every frame sometimes, and it just doesn't take it's not a hiccup, not a single like 0.01 ms, nothing. It's just because it's so fast to deal with data. Like structural changes in the ECS is heavy, and you should just try to avoid that completely. If you have a system that would just chug on with tens and tens every frame, you can just avoid creating entities unless you want them globally identified, like we talked about. But so when I remember when we talked about this, and I said I can bring up how you can do this without entities, and somebody said like, yeah, how could you do that? But I think data oriented design, you need to like, everybody needs to like think about like what data do I actually need?
Right.
Well, I need the damage and I need the targets. That's
Yeah.
it.
Data
The
oriented design isn't about, using an entity component system for everything. It's about looking at the data that you have and then how do you most efficiently process that. Sometimes, yeah, ECS is going to be a great solution for it. But I really like, a couple things that you've showed where you're just kind of ignoring some of the Unity ECS stuff and say, no, like the more efficient way is to do it this way, and that's how I'm going to do it.
Yeah, and like there's a lot of times where having it attached to an entity makes it like go through different channels in a very nice way. So for example, like you have the query system where you can just get the thing that you want, and if it's slightly complex where you have like the entity and you can like put on some damage on it, you can put up a debuff on it, you can put up something else, and you can like build a complex event of it that then like deals some effect to the enemy. And I think that's partly what you did with your system. So that type of like a building block system where you can like build up the event to be more than just the damage event, in that case is very good. But also realize that you could also just shove all that data into the same structure, right? And just have one structure, one behemoth structure, and
Right.
just
Yeah.
put it in. And maybe behemoth structure, even the word sounds like a bad idea performance-wise, but possibly it can be faster because you don't have any structural changes.
No, and I've heard of that kind of being a viable solution for other different types of things where people, just basically make like a mega struct that contains like every single bit of
Yeah,
data that you would want to track. And, if there's a flag set in there, handle what you need to. But yeah, and also I know another thing that you've kind of mentioned about is like the cascading events, and I know your friends over at Stunlock Studios have done some interesting things with some of the cascading events that they kind of were talking about. I think on that live stream that they did with Unity quite a while ago that is now up on their YouTube channel.
yeah. Oh, right. Yeah, I bet they have a ton of that because they don't have as much enemies as me, but the cascading events is probably like 5 times more complex than what I have because
Yeah.
it's a lot more complex game. Yeah, we can just take a quick look into the signal system here. It could be named event system just as well. I just wanted to distinguish in my mind when I
From like the
wrote.
keyword event. Yeah.
Yeah, yeah, yeah. But here we have. I have two different ways of dealing with this, which is this is a very fascinating thing, and I can explain kind of quickly. But here we have just like the list, and since this is not a lot of stuff inside of here, I can just use a managed list, and I don't have to deal with unsafe lists, which is the only thing that can be nested like this. So I just
Gotcha.
have a normal list. It doesn't really matter,
Nice. Yeah.
and it won't be that many. It's only as many as there are system who uses this every frame. So maybe like 5 or something.
Okay.
Yeah, but otherwise, I have this. I thought about like so when you go into we can look at the shotgun gun. That's yes. Um, so if we take a look at this one, we have all of these different signal systems. So here we have all of this works the same way. So we have particle producer, camera shake, dust simulation. That's for when you shoot, you blow out the dust around you. VFX, play, muzzle flash. Yeah, those are the ones that I have here. Um, and this update loop can run once for every shotgun, right? So that means that they can at maximum be 4 of these running every frame because there's 4 players and everybody can have one shotgun. So it feels silly to me to create a full native queue for this single update loop, which can really so imagine all of these would create a thing in one native queue each to put into this one for them to produce their output signal, like the damaged native queue that I showed. All of these guys could be that native queue, but it feels silly to give them, I don't know, 6 different native queues, and then all of the other guns have the similar thing where they also need their respective things. Then it just becomes a frenzy of native queues all over the place for just a few entities, for for shotgun maximum, which is silly. So I created this other thing, which is signal slots. So if we go to this one, this is basically like a struct that has a reference to an unsafe list, and then it has a reference to a bit array, which is just on-off switches. And then when you ask for this signal slot, you get back this component, or this struct, which is like, okay, so I have reference to this big single array, and I just reference the start index here, and then you have access to 4 slots. And then the next thing that calls this same signal slots, it just gets the next set of 4 slots in this
So
big
just kind
array.
of increments that.
Yeah, so all of the weapons, basically all of them have like the VFX thing where they produce VFX, for
Okay.
example,
Yeah.
and they all just share the same unsafe list of a bunch of slots where they can every frame like shove in like, I want this effect, I want this effect. So and this is just kept alive and just cleared out for every frame. So I'm just like handing them, shotgun, you have these 4. Say, tell me if you need any effect, and then and that can happen in parallel with anybody else because I disabled all the safety systems around that. So all the different guns can just like they have their little space in this list, and that's it. And that way, for all of these tiny systems that just produce a little bit, they don't need their own native queue. They just get a little bit slice of a bigger list. And I realize as I speak about this that this could possibly be done with native slice. I didn't know about native slice when I wrote this like 3 years ago. So
Maybe you have to delay the game by another week or so to.
to
No, no.
implement, yeah, so many times I paused it out. But yeah, so that's very much, there's no magic to it. There's like, just have lists with the stuff you need to do, and then like, okay, shove the stuff into this list which you want to happen, and I'll read it when you're done. That's the basic thing. You just need to shove data through native lists. Just communicate as much as possible between different stuff with just data in lists. You don't need entities for a lot of stuff. I think there's a lot of ways where entities, where going outside of the entities are the most horrible and annoying thing ever, and you should never do it. But there's also stuff where you will never read the index of the entity. You will never care the identity
That's a
of
good
it, and it
point.
won't
Yeah.
matter.
Yeah.
So every time you don't need entity, just, yeah, you can just,
Just use
it
regular.
will
Yeah.
take longer to code, but it's not that bad, and it will be just void. It's not like you don't even need the structural change. You just, there's it won't affect anything. It's just your data here in this array. That's it. So yeah, that's how you do events without entities.
That's a great point. And then, so as far as like processing those events go, do you just have like some kind of system that iterates through that full list?
We can take a look at the VFX, because that's a pretty VFX, if I can spell right, system.
Yeah, we can just do a
Got a
quick
pretty
one on that.
straightforward
And
here. So let's see here. Blah, 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 blah. On stop running, clear effects. I got some. This is managed game object types. It's the
right,
VFX
right,
graph.
right, right.
So there's a bunch of caching here. There's no other way to do it. So I instant like 256 bullets on startup and just keep them disabled. But I don't know. There's nothing to do about that. So here we have update. So this is a little bit like generalized in a way that may be hard to follow, but we should basically just look at like maybe process queue or process list. So imagine this being just the loop around all of the stuff that you produced. It's just a little bit abstracted here. But so this is just a native list of the signal create effect, and we can look into that. And we have like an owner, event ID, owner net ID. We have the position, and this one isn't actually ordered by size. I realize now this is an old structure. I should just reorder it so it's more effective in the space wise.
Although I think C sharp might kind of do some of that ordering behind the scenes for you, as long as you're not specifying the ordering.
No, it's actually doing it's explicitly through exact same order that's as C has, because it wants interoperability with C and C++. So it's doing a specific ordering, which is you can do explicit ordering and make it better and make it exact as you want. But right now, this is probably maybe twice as big as it should be, because I can see like a quaternion here that just screws up all the ordering very hard. This one is like 64 bits, and this one is 32, so already there. But that's complicated. Anyway, it's not really that relevant. It doesn't matter that much. But if you have 10,000 of them, then you should order it properly to make sure that it doesn't take up extra space.
Yeah.
But I'm pretty sure that C# runtime by default doesn't reorder anything in sizes. But I might be wrong. Maybe some update. Anyway, this is not really relevant. So this is the thing that I'm sending out. So the big thing that's really relevant here is position, rotation, and effect type. And we can just see this. This is just a long list of all the effects in the game. Not a lot, actually. Well, there's a lot of other effects, but not in the system. So I produce this, and I say where it is supposed to be, what scale, lifetime, and all that stuff, all that nice. And then when I consume them, I have this list, process create signal. Then I just, this is a special case for optimization, bullet hit concrete, a lot of them. So I have a very specific type of way of doing that. But otherwise, yeah, here we go. So create event. I have a function that gets the exact event cached. So here's the instance of the visual effect event, visual effect, not the event anymore. It's the actual game object that's supposed to be shown. So, and it might be cached, might be created if I already ran out of them. And then I reinitialize it, I play it, I put it on the right place, and I set all the stuff that I can do if I have something to set, the floats, length and power and lifetime and all of that. And if it has an owner, I make sure to pick out the owner's position and or if it has an owner, then I start tracking it. So I have like a tracking system where it's like this entity owns a few effects, and every frame I need to update the effects with the position of the entity, right? So, but if it doesn't have an owner, it's just a one shot, and it's just like bam, and when it's over, it gets destroyed. But there's nothing more than this. Like there's, you can go into this one as well. This is the type. It's just a big cache. If I have any any available, I pop one from the cache instance. I activate it. I turn on the lights if it's the lights inside of the effect, and then I return it, and then I do whatever I need to with it. So there's like this consuming of effects of events. That's just, you just pick out the list that's filled in with stuff you need to do,
Yeah,
and you just start
straightforward.
processing
Yeah,
it.
yeah. I like it.
Yeah,
Good straightforward
yeah.
solution.
Yeah, there's surprisingly little amount of magic behind any of this, and I guess that's once again they are in the design. It's a little bit anticlimactic in certain situations, because it's just, there's no abstractions in a lot of
Okay, just
situations.
throw it in an array and iterate the array. Boom,
Yeah,
easy.
yeah, and that's what's fastest on a computer.
CS
So
101 stuff. So
yes, indeed. Um, yeah, I guess that's the events system, sort of, or signal, or
cool.
data. I don't
No,
know.
I like that approach a lot.